This is the homework for 8th grade math, SBAC review, part 3. For number 1, does the mapping diagram represent a function? Well, anytime I see a mapping diagram, for me it's easier to put them as ordered pairs. And remember that for it to be a function, the x values cannot repeat. So I'm going to go ahead and put these as ordered pairs, -1, 0, 1, 0, 0, 0, and 2, 2. So here, if you look at it, none of the x values repeat. You can see that the y values repeat, and that's okay, but the x values cannot repeat. For number 2, we need to determine if the graph represents a function. Well, the graph is the easiest one to determine whether it's a function or not. You want to see if it passes the vertical line test. So if I take my pencil and I place it vertically on the graph and go across, at any point, if you have two x values on the same line, then it's not a function. So this one does not pass the vertical line test. For number 3, is the relation a function? Well, again, I have a mapping diagram, and I'm going to write them as ordered pairs. So I have -7, 3, 11, 5, and 11, 8. So if you see that the x values repeat, so if the input or x values repeat, it is not a function. They are paired with two different output values. For number 4, is the table a function or not a function? This is clearly not a function because the x values are repeating. For number 5, which set of values is a function? Well, the only one that doesn't have x values that repeat is C. All of the others, A, B, and D, have repeating x values with different output or y values. For number 6, we need to find the slope from the graph. Well, remember, slope is rise over run. So if you look at this from any of the lattice points, we take this lattice point, there is no rise. So the rise is 0, and then the run goes on infinitely in both directions. So 0 divided by any number other than 0 is going to be 0. For number 7, we're going to find the slope of this line. Well, again, slope is rise over run. So I'm rising, and it's going to go on infinitely, my rise, but my run is 0. I'm not going to the left or to the right. So you can't have something of nothing. So if you have 0 as the denominator, then, so here's an example, 5 divided by 0. You can't have 5 of nothing. So it's undefined. And remember the vertical line test. This does not pass the vertical line test. For number 8, which of the following is in slope-intercept form? That's y equals mx plus b. M is the slope, b is the y-intercept or initial value. And the only one that's in slope-intercept form is A. Slope is 10, y-intercept is -7. For number 9, what is the y-intercept of the following equation? So the value in front of the x is the slope. The slope is -4, and the y-intercept is -5. For number 10, we need to write the equation 4x minus 2y equals 10 in slope-intercept form. y equals mx plus b is in slope-intercept form. So we need to get y by itself. And this is a good way of, when you're doing system of equations, to use substitution method to get one of the equations in slope-intercept form. So we first have the given equation, and we're going to subtract 4x from both sides of the equations. Here we have a zero pair. What you do to one side, you do to the other. And now we have negative 2y equals negative 4x plus 10. And we have to get rid of this negative 2. So we're going to divide by negative 2 to create that big 1. And remember, it has to be a negative because it's negative 2 divided by negative 2 equals a positive 1. And what you do to one side, you have to do to every term on the other side. So you can't just divide one of these terms by negative 2. It has to be each term by negative 2. So negative 4 divided by negative 2 is positive 2. Positive 10 divided by negative 2 is negative 5. And now it's in slope-intercept form, y equals mx plus b. 2 is the slope. Negative 5 is the y-intercept. For number 11, give the slope and y-intercept of 6x minus 3y equals negative 9. So we have to put it in slope-intercept form, y equals mx plus b. So first I'm going to subtract 6x from both sides of the equation. Remember, we're trying to isolate the variable. We want to find out what y equals. So here's a zero pair. And now I'm going to use commutative property of addition to rearrange. I want the x term to be first because the slope, y equals mx. So now it's starting to get into slope-intercept form. And I have negative 9, negative 9. Now I have this negative 3 multiplied by y. Inverse property of multiplication is division. So I'm going to divide by negative 3 to create the big 1. And what you do to one side, you have to do every term on the other side. So I divide both of these terms by negative 3. So now we have the big 1. Negative 6 divided by negative 3 is positive 2. Negative 9 divided by negative 3 is positive 3. So the slope is positive 2, and the y-intercept is positive 3. For number 12, which is the graph of y equals negative x plus 2? Well, first I'm going to look at the y-intercept. And the y-intercept is where the line intersects or crosses the y-axis. So it crosses at positive 2. Well, I can see that this is crossing, it looks like at a positive, 2. This one looks like a negative 1 or negative 2. It's hard to tell, or maybe even the origin. This one has a, could be positive 2, but it looks much higher than positive 2. And then this one is negative. So it has a negative y-intercept. So really the only two that really work are A and C, because both of these have a negative y-intercept. Now I want to look at the slope. And I see that this has a negative slope. So remember, the negative, if it has a negative slope, I say that, think of the as a tree falling. Is the tree falling towards the negative x's or towards the positive x's? And you can see the only one that seems to be falling towards the negative x's is A. And this has a negative slope. And if you think of rise, positive rise, negative run. So that's a positive over a negative. This one's a positive over a positive. This has a positive slope. So the answer is A. For number 13, what is the slope of this equation? Well, in the yellow, positive 4 is the y-intercept. or the initial value. The slope is -3. For number 14, we need to find the slope of the line. So I have my two lattice points here, and slope equals rise over run. So this has a rise of 1 and a run of 2. So the slope equals 1/2. For number 15, what error did the student make when plotting the points 3, 4 according to the picture? Well, remember, your ordered pairs are written x, y. So that means 3 on the x, 1, 2, 3, and 4 on the y-axis, 1, 2, 3, 4. That would, 3, 4 would be here. But this point is 1, 2, 3, 4 on the x, 1, 2, 3, 3 on the y. So this student switched the x and y coordinates.